Hi everybody. So today we're going to be tackling fluids. A lot of us have a pretty good concept of what fluids is about already, but hopefully I might just be able to clarify some things that you might be a little bit confused about. So the first thing I want to talk about is density. So density is a measure of how packed a material is, and we use the sign rho to denote density. This is given by mass over volume, and basically this shows how many how much mass there is per a meter cubed or something, for example. And that being said, the units of density are given by, for SI units, kilograms per meters cubed, right? And that sort of allows us to contextualize what density is. It's how much mass you have per amount of a material. So just remember that. The next thing I want to talk about is let me see. I'll talk about specific gravity, and this a lot of the time is denoted by SG. And specific gravity is basically a ratio. Specific gravity, some people will say it has units, some people will say it doesn't have units. It's basically the density of whatever object you have. So I'll just say density of material over the density of water. And we use that water because water is an easy reference point for us, right? We know the density of water a lot of the time. So the density of water is given by, I'll just put this here, 1 gram per centimeter cubed. So I'll say this. But a lot of the time, like I said, it's going to be given in kilograms per meters cubed, right? So it's 1,000. And I'll put equal signs here, actually. And then it's going to be your density of whatever material you have, right? So in the next video, maybe I'll do an example of it or something. But that's what you need to know. One thing you need to know about specific density, if the specific density, specific gravity, I've been saying specific density, specific gravity, right? SG, specific gravity. If it's greater than 1, that object is gonna sink. If it's less than 1, that object is gonna float. So maybe if I have, let's say, an object is floating in, I'll just do it a straight line, in water, right? Let's say I have half of that object. Pretend that's half of an object. But let's say half of the object is above the water. When I drop it, it settles, right? And half of that object is above the water, half of that object is below the water. The specific gravity of that object is 0.5. So half, that's why it's 0.5. If a third of it were submerged, it'd be 0.75. And that's an easy way to sort of know what the specific gravity of an object is. Next I'll talk about pressure. The reason I'm talking about all these terms is they relate to fluids, right? So basically with pressure, there's one formula you need to know, and that formula is that pressure, which is just denoted by P, is equal to force over area. And this is given by the SI units. Forces are newtons, area is meters squared. So you might have that, but a lot of the time we have pascals. So basically 1 pascal is equal to 1 newton per meter squared. So science likes to name things after people. So the guy that discovered pressure, I think his name was Pascal. So it's a newton per meter squared, but we call it a pascal. So just remember that. The next thing I want to talk about, actually, you know what? We're gonna end it right there. So these are just basic points that you need to know about fluids and everything. Hopefully, as we do example problems like these, you'll sort of start to understand how these are used and the concepts behind them and everything. But as always, if you have any questions, please leave them in the comment section. Hopefully I'll do my best to answer them. Don't forget to like and subscribe, and let's keep learning. Okay? Thanks.